Okay, everybody, numeric response number 10. We're going to find the intervals of concavity for x cubed over 9 minus x squared. So obviously we're going to have to take the derivative twice here. So I'm going to take the first derivative, and it being a rational, I will use the quotient rule. So what do we got here? We're going to have 3x squared, 9 minus x squared minus x cubed, negative 2x for the bottom there, and then we square the denominator. Okay, well, obviously I'm not going to take the derivative right away. I'm going to simplify that a little bit. So what is that? That's going to be 27x squared minus 3x to the fourth plus 2x to the fourth all over 9 minus x squared squared. And what are we going to get there? Well, let's just put this in the right order here. Negative x squared plus 27x squared over 9 minus x squared squared. Okay. Well, I don't think that's going to get much prettier. So let's just jump into the second derivative. Okay, and I'm just going to keep going down here because I've got the room. So y double primed. And, okay, this is this is going to get big. Okay, negative 4x cubed plus 54x times 9 minus x squared squared. Okay, so now I can see coming up here there's a chain rule coming. It's not going to be pretty, but anyway, minus negative x to the fourth plus 27x squared. And here we go, off to the side here, 9 minus x squared times negative 2x. And that is all over 9 minus x squared to the fourth. Okay, a lot going on there. That's okay, let's keep going here. I'm going to factor out the 9 minus x squared, see if that gives me anything pretty here. And when I simplify what's left over here, I got to FOIL this out. So it's be minus 36x cubed plus 4x to the fifth plus, okay, that's okay, that's 486x minus 54x cubed minus 4x to the fifth plus 108x cubed, and this is all over 9 minus x squared to the fourth. Yeah, okay, a lot going on there. Kind of busy. Those two obviously cancel. But I got a lot of cube terms there, so that's kind of good. And then the 9 minus x squared will cancel with one of those. And so, okay. Sorry, it's a little early in the morning here for me right now. This is 18x cubed plus 486x all over 9 minus x squared cubed. Okay, see now that got cute real fast. And I'll take out the common 18x there. And this is over 9 minus x squared cubed. Okay, so now at this point here, to determine intervals of concavity, I'm looking for where the second derivative is either 0 or undefined. I can tell you right now it's undefined at plus or minus 3 because of the denominator. You can see that coming right away here. Now the numerator got two factors here. My critical number, okay, is going to be 0. Now remember, the critical numbers x plus or minus 3, those don't count. It's quote-unquote critical numbers. But 0 would. These guys aren't in the domain, and there's no way x squared plus 27 is going to go to 0. They just won't happen here. So we can put these guys on our number line, and let's just talk about what's going to make these things, the intervals positive or negative. If I choose a number less than negative 3, this will be negative, this will be positive, this will always be positive. If I choose a number less than negative 3, like let's say negative 5, this becomes 25, this becomes negative, and then the cube keeps it negative, so negative over negative, this becomes positive. If I choose a number between negative 3 and 0, this is negative, but this is going to be positive because this isn't going to be big enough to balance out the 9. So this will be negative. In this little domain right here, the numerator, that goes positive, this stays positive, so positive. And then for the same reason that switch signs out here, this will be negative. So this is going to be concave up on negative infinity to negative 3, union 0 to 3, and it's going to be concave down on negative 3 to 0, union 3 to infinity. And those are my intervals of concavity.